Well, hi there. Thanks so much for showing up for your math learning. Today we're looking at triangles and getting started on some geometry and measurement together. So today's about learning the vocabulary, applying the vocabulary, and playing around a little bit with some angle properties as well. So you want to be very clear on the different types of triangles that we can have and the different vocabulary. So I would go through with a highlighter and highlight these potentially new words: scalene, isosceles triangles, equilateral triangles, and then take a look at the diagrams and see how these triangles are what they purport to be. This one here is scalene, similar to the triangle that I've drawn in Desmos for you here. This one is also scalene. One side is 3 long, one side is 4 long, and I wonder what the other side is. And then we can also classify triangles by the types of angles in them. This one is like, it's not my favorite diagram right here, because this really looks like a right angle, doesn't it? But if this is an acute triangle, this is an acute triangle, all of the angles are less than 90 degrees. So maybe this one is like 80 degrees here, and this one could be 60 degrees, and well, so let's say 40. This would work, and this one could be 60 degrees. So it could be a triangle like that and be an acute triangle where all the angles are less than 90 degrees. Right triangles are very special, and we create a lot of these. They're very important. So we're going to be spending a lot of time with right triangles. That's where two sides are connected by a right angle. The triangle that I created in Desmos, because it's on the XY plane, and I have these points here at 0, 0, 0, 3, and 3 comma, wait, no, 4 comma 3, because I have these points, and the points are along the X and Y axis there between, like around that green point. This angle here at the green point is a 90-degree angle because the X and Y plane are at 90 degrees to one another. And so the coordinate plane is connected with these triangles as well. We're going to use that tool a lot. Obtuse triangles are a little more. There can only be one angle in a triangle that's greater than 180 degrees, sorry, greater than 90 degrees, and between that and 180. And because triangles, all of their angles, here's another property of triangles: angle A, angle B, and angle C have this property: A plus B plus C will always equal 180 degrees. And so you'll see this triangle up here certainly works. 80 plus 40 plus 60 is indeed 80 plus 100 is 180. Okay, so go through and classify these different triangles by the type of triangle that they are. And then you're also given triangles with side lengths, and you have to tell me what type of triangle they are. If you don't think that a triangle is possible, tell me and tell me why. Let's say it's in there on purpose. Okay, all right. So now, angle properties. So here are some other things about angles that we want to know before we start moving forward with other types of problems. These problems are very common on EQAO, so you're going to want to have this as well. When we have a straight line, like this is a straight line, if I were to say turn halfway around and go back, that's a 180-degree turn. You can think about it like if you're a skier or a snowboarder, if you hop up and turn so that your tips are now pointed up the hill, that's a 180. Okay, so if you have two angles that together make a straight line, then this equation is true. They add together to make 180. Now, these are things that I often find grade 8 students know, but they don't apply them with equations. They just know that that's a principle. So now, because you have more solving equations skills, you can use those skills with these equations. So actually using those very well. In these cases where two lines intersect, the opposite angles are equal. I call this the kissing bird pattern because you see if I draw this here, this is a bird with its beak, and then this over here is another bird with its beak, and they're kissing. So the opposite angles are always the same. That also means that these angles are the same here. C equals D in this case. So set up your equations and work with it that way. Okay, now over here, we've already talked about this. If you take the three angles of a triangle and add them up, they all add up to 180. It's very cool. All right. Now, these next three all have to do with having a set of parallel lines. Okay, there, and there. They all have to do with the set of parallel lines, and there's angles that are the same in lots of different places. But in all cases, you can use this property and this property to work out what all the other ones are, given any one angle in these cases. So when we have this line here that crosses two things, you can think of those parallel lines as like two edges of a street, and this is the chicken crossing the road. Okay, and the chicken crosses the road on an angle. All right, the angle that the chicken leaves at will be the angle that the chicken arrives. It's just what it is. But then if I know that those two angles that are dots there, if they're the same, then by the kissing birds pattern, this one over here is also angle dot, and that one over there is also angle dot. So I only need to remember this one called Z pattern, or alternate angles. So they alternate around the same side. And that will give me this corresponding angles pattern here, which some people will call F pattern. Okay, where those two angles are the same. But of course, because this is the same as this through kissing birds pattern, or opposite angles, and that's the same as that, then we can get F pattern on the other side. You can get a Z pattern there. You can get all your patterns from just looking at that. And then this last one is these two angles together, these two dotted angles, they always add to 180. But that shouldn't surprise us. Okay, I'm going to color this one blue, and I'm going to color this other one red. Okay, so you'll see the blue angle is different from the red angle. We can clearly see that that's true. But that red angle is going to be the same as that one up there because Z pattern. Okay. And by that logic, this one up here is also the red angle, and that one down there is also the red angle. Not by Z pattern, but just because they're opposite one of those. And then I'll fill in all the blue ones. They fill in as well. They're boop, boop, and boop. Okay, so those are all the blue angles by Z pattern or whatever pattern you want, really. They're all the same. Okay, and then, so we're told here that if I do blue plus red angle, that should add to 180. And indeed it does. Look, it does here. So it certainly will as well in what some people will call C pattern here, because this makes a C. Okay, like the letter C there. And so angles in C pattern that are connected inside those two parallel lines will always add to 180. But we can see that as well just by filling in all our angles and seeing that they add to a straight line there, or indeed they add to a straight line here, or they add to a straight line there. They're a straight line in a lot of places. Okay, so we can get that equation that like blue angle plus red angle equals 180. Pretty straightforward. All right, so those are the angle properties. Use those to go ahead and find the measures of the different angles down here and work through those and practice all of these. And then, yeah, extra practice problems for you there. So any questions? Ask me them tomorrow when I'm in the building, or hit me up by email. Otherwise, thanks so much for showing up for Math Learning, everyone. Bye for now.